In this example, I need to solve the following equation on the interval 0 to 2 pi. The equation is 2 cosine squared x plus sine x minus 1 equals 0. Well, what type of equation is this? It has trig functions in it, so it's a trigonometric equation, and the highest exponent on any of the trig functions is a 2, so it's a quadratic trigonometric equation. Now, when you have more than one trig function in an equation, you want to separate them if possible by factoring. That's not going to work in this case. So what I'm going to have to do is rewrite this equation in terms of just one trig function. Now, it's much easier to rewrite cosine squared x in terms of sine squared x than it is to write sine x in terms of cosine x. So I'm going to need to use the Pythagorean identity sine squared x plus cosine squared x equals 1. And from this identity, we know that cosine squared x is equal to just 1 minus sine squared x. So now I'm going to rewrite my equation. I'm going to have 2. And instead of cosine squared x, I'm going to write 1 minus sine squared x plus sine x minus 1 equals 0. Now, all I have is one trig function, the sine of x, in my equation. So simplifying, distribute in the 2. 2 times 1 is 2. 2 times negative sine squared x is negative 2 sine squared x plus sine x minus 1 equals 0. Collecting up like terms and writing in descending order, negative 2 sine squared x plus sine x, and then I have 2 minus 1, which is just plus 1, equals 0. Now I want to factor this quadratic equation. It's much easier to factor when the leading coefficient of the squared term is positive, so I'm going to multiply both sides of this equation by negative 1. And multiplying by negative 1 will just change the sign of every term in the parentheses. So I'm going to get positive 2 sine squared x minus sine x minus 1 equals 0. So I have a quadratic equation in sine x. It's fairly simple, so I'm going to factor it by trial and error. Multiply to 2 sine squared x. I need a 2 sine x in the first parentheses and just a sine x in the second parentheses. Multiply to 1, I just have a 1 and a 1. Now multiply to a negative, I have to have opposite signs, but they need to add to negative sine x. So 2 sine x times 1, that has to be my negative, and then I have to have a positive in this parentheses. Double check by foiling. 2 sine x times sine x is 2 sine squared x. 2 sine x times negative 1 is negative 2 sine x. 1 times sine x is positive sine x. And negative 2 sine x plus sine x is negative 1 sine x. And lastly, 1 times negative 1 is negative 1. Now we've factored it, set each factor equal to 0. So 2 sine x plus 1 equals 0, and sine x minus 1 equals 0. On the first equation, subtract 1 from both sides. 2 sine x equals negative 1. Divide both sides by 2. And I'm going to get sine x equals negative 1/2. And from the second equation, add 1 to both sides. Sine of x equals 1. So the solutions to this equation come when the sine of x equals 1 or it equals -1/2. So going to my unit circle, remember the sine is equal to the y-coordinate of points on the unit circle. So when the sine of x is equal to -1/2, that means the y-coordinate is negative, so it's below the x-axis. So I'm going to be in quadrant 3 and quadrant 4. And the y-coordinate equals -1/2 right here when x equals 7 pi over 6. And also over here when x is equal to 11 pi over 6. So those are two of the solutions to this equation. Now when the sine of x is equal to 1, that is up here. And so in that case, x equals pi over 2. So this equation has three solutions in the interval 0 to 2 pi. And my solutions are 7 pi over 6, 11 pi over 6, and pi over 2.